function, we would have 2. So square root of 0 is 0, square root of 1 is 1, square root of 4, I know, I tried to delete it, but I have them grouped together. So 9, 3, so there's my parent function. Okay, what does the 1/2 out in front do?
Shrinks it.
Right, it is a vertical shrink. If you wrote out your order pairs, what it does is take your y value times 1/2. What does the +2 do?
Left 2.
What does the -3 do?
Down 3.
Okay, so if I take this point, my y value is 0, times 1/2 is still 0. Then I take it left 2, down 3. All right, here my y value is 1, times 1/2 is just 1/2. Left 2, down 3. Here my y value is 2, times 1/2 is 1. Left 2, down 3. I'm not writing out order pairs. Are you guys following me?
On the test, is there going to be a graph?
Yes, on a test I will put a grid for you. Here your y value is 3. If you took that times 1/2, it would be 1.5. Left 2, down 3. So we get our same graph, but it's a little bit shorter and it's been moved over. Is that one okay?
Yep.
I want to do there's one on the Math Excel like this. So it gave you a graph.
This one's kind of the wrong place. I just like doing it.
Oh, that's good to know.
I got 97 on it, but that was one I missed.
That was the one you missed.
Oh, I
That's
got it.
exactly why I'm choosing to go over it right now.
It looks-
All right, so here's my parent
That's
function.
the one I was on.
This is kind of what I said. You don't want to rely too much on your graphing calculator to show you what the transformations look like because I didn't give you the equation of this original one. So is there any way you're just going to plug it in your calculator and get the graph?
No.
No. So we have to kind of have an understanding of what our transformations do. So when I look at this one, if a negative is out in front, it's essentially making all of my y's negative. What does that do to the graph?
Flips it over the y-axis.
Over the x, right? If you think about it, if I take these actual points, this is 2, 6. If my y becomes negative, where does it go? That's going to go to 2, negative 6. This would go to 7, negative 6. So that little piece gets moved down here. This was at -1, -3. Where does it go?
A 3.
-1, +3. -4, 0. Does that move?
No.
No. If I make my y negative, there's no negative 0. It's the same. Oh my goodness, I'm missing my points today. But we get something roughly like that. All right. This one. If I make my x's negative, what does that do?
Over the y-axis.
So if I take my original, if I make my x's negative, so this would go to -2, 6, -7, 6. So that horizontal line just comes over here. -1, -3 would go to +1, -3. -4, 0. Okay. So same general shape, but it just gets flipped around like that. This one okay?
All the graphs touch at -1.
They should, yeah, these two meet at 0, 0. If my graph is drawn perfectly. Okay, what I have now, adding to your x moves it to the left. So if we take the point 8, 12 and go left 4, it went to 412. You could think inside is x and it does the opposite. So adding 4 means I subtract 4 from my x. So this one is on the outside. What does that plus 4 do? Up 4. Outside is y and it does what it says. So we started with 812. If we went up 4 or we added 4 to our y, you should get 816. C, 1/4. So it's on the outside, so it's x, so it's so it's y, so it's a vertical. 1/4, what would that do? Stretch or shrink?
Stretch. No, shrink.
Shrink, because it's less than 1. Okay, make sure everybody's with me here. So, we are on the outside. I'm not talking to you. Pay attention to me. So, outside is y, and it does what it says, so it's like taking your y times the 4th. So you get 8/3. Okay, D, it's also on the outside, so it's still vertical, but this time you're multiplying by something bigger than 1, so it will stretch. Outside is y, and it does what it says. So you take your y times 4, and you get 8/48. All right, E, inside is x, and it does the opposite. So x is horizontal. It does the opposite. So bigger than 1 will shrink. That's the opposite of what we think. So if we take the point 812, we're changing x, and we do the opposite. So instead of multiplying my x by 4, I divide it by 4. So we get 212. All right, last one is inside, so it's x, so horizontal. Does the opposite of what we think, so this one would stretch. Okay, it says multiply your x by a 4th, so you divide it by a 4th, or think of it as multiplying by 4, and you get the point 3212. How did we do on those?
I just mixed up stretching.
Okay. Number 2. So, my parent function is the absolute value. Exact points. 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. If you don't have those points where I can see them plotted on your graph, you will automatically miss a point, even if the shape is correct. I want to be able to see those points. So, what does this negative 2 do?
Flips it over
It's gonna
and stretch it.
flip it and stretch it. If you wrote out your points, if you struggle with the stretching, you could do this. It's on the outside, so it's going to change my y values, and it does what it says. So essentially, we're going to go through and multiply all my y's by negative 2. Alright, so if all I were doing were the negative 2x, these would be my points. But what else do we have to do here?
Left 3.
We also have to move to the left 3. So, 0 times negative 2 is definitely still 0, isn't it? Nah. Alright, so this one, when I multiply my y by negative 2, it's still here. And then we go left 3. Okay, 1, 1 would flip and move to 1, negative 2. Left 3. You probably didn't put on this next point 2, 4. Or why did I write 2, 4? Oh my goodness. Am I not really with it today? Yeah. I think I already multiplied it by 2 when I wrote down my points. How about 2, 2? So then when I multiply my y times 2, it would go to negative 4 for both of those. So 2, 2 would go to 2, negative 4. And then left 3.
Do you have to have 5 points?
No, only 3. I just put extra to show it. So negative 1, 1 would go to negative 1, negative 2. And then left 3. 2, 2 would go to 2. Sorry, negative 2, negative 4. And left 3. So we get a skinnier upside down graph. Minimum of 3 points on both the parent and the final one. All right, this one I think everybody did pretty well with. Parent function is the square root. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. If you went one more, square root of 9 would be 3. A lot of times I may ask you to describe your transformation. What's going to happen on this one?
Left 2, down 2.
Alright, so take each point to the left and down. So we get this graph. I didn't ask for it, but could you guys tell me domain and range on that? What is your domain?
Bracket at 0, positive infinity. No.
-2 to
Bracket
infinity.
Oh, you're talking about
What is the range?
bracket -3 to infinity. I was talking about
Is this one increasing, decreasing, or constant?
increasing.
Increasing, good. So I could still ask you any of those questions. All right, this is not the one that you had on yours. I did 2x squared plus 1. This was probably the most challenging one
Nah.
for most of you. So 0 squared is 0, 1 squared is 1. You could do 2 squared is 4, -1, 1, -2, 4. So we have the parabola for our parent function. Okay. If you wrote out your ordered pairs, inside is x and it does the opposite. So what am I going to end up doing to my x's? Multiply by a half or divide them by 2. Okay, so if all I did were the 2x squared piece, I would divide all my x's by 2, and we would get these points. And then what else do we have to do? Alright, so take 0, 0, move it up 1. This point would go to 1/2 1, up 1. This point would go to 1, 4, up 1. -1, 1 goes to -1/2 1, and moves up 1. -2, 4 goes to -1, 4, and then up 1. So we get this graph. So that was a horizontal shrink. It's like we came in from the sides and mashed it in. All right, is that okay? Let's talk about these. So these are, again, those questions that I might give you that you can't use the graphing calculator on, and you just have to know what your transformations are going to do. What does the -2 on the end do?
Down 2.
Down 2. So what you need to do is take some exact points on your graph and move each of those down 2.
You told me that pointed point was.
Yeah, this pointed one. I know some of you put it exactly at that point. It's really kind of a little past. So, and then you follow the same shape. So it's curved there, comes down to a peak, and kind of swoops up like that. What does this one do?
Right 2.
Right 2. So if we take the points and move each of those to the right 2.
Oh my gosh.
Okay. See what's happening.
Left and up 2.
Alright, so take these points. So I need to go left and up. This left and up. Alright, the last one is probably the most challenging one here. So what does the negative on the outside?
Flip it across the S. I mean, no.
Flip over the
It's over.
Okay,
S. What's the -2?
right 2.
And the plus
I
3?
didn't really done.
Okay, when I talked about what order to do these things in, I said it didn't matter except what has to be the last thing we do?
Up.
The up 3. Okay, so let's talk through this. If I take this point and flip it, does it go anywhere?
No.
No.
And then I need to move it right 2 and up 3. My board keeps freezing here. Okay. So if I take this point and I flip it over the x, it comes down to -2. And then we go right 2 and up 3. If I take 0, 0 and flip it, it doesn't go anywhere. And right 2 and up 3. If I take 1, that's about -2.5. If I flip it, it goes to +2.5. If you thought it was at +2 exactly, that's fine. Then we go right 2, up 3. And this one, when I flip it, comes down, right 2 and up 3. Same general shape, just upside down. Okay, how do we do there? Good. All right, final question of the day. Can you tell me the domain and range for A?
-4 to 3. Bracket on both.
Uh-huh. What is my range?
-4, -2. Brackets.
Negative.
Or -4.
-4, 0.
Yeah, this is at, if you put -4, I do too, it was kind of hard to tell from the original. It's really about -4.5, and it stops at 0. So, if you're done with your Math Excel, just please keep the volume down, because there are a few people that do need to finish that up.